If you're listening to this right now, you might believe you already know the story of petroleum. You've heard the textbook explanation. Crude oil is nothing more than the compressed, liquefied remains of ancient marine organisms. Algae, plankton, microscopic creatures buried under layers of sediment for millions of years. Heat, pressure, time, and voila, the black blood of civilization. But as you and I begin this journey, I want you to challenge every part of that narrative. Not because it must be false, but because the parts that don't quite add up often reveal the most interesting truths. Think for a moment about what we're told. Vast oceans filled with tiny organisms die, sink to the seafloor, get buried under mud, and over geological ages turn into hydrocarbons. Seems simple, almost elegant. Yet when you look closer, the first cracks appear. If petroleum is truly just the remains of ancient life, then why is it concentrated only in very specific regions of the world? Why not evenly spread across every coastline, every continental shelf? After all, plankton didn't choose Saudi Arabia over Scandinavia. Algae didn't avoid Australia or Antarctica. Life was everywhere, and yet the oil isn't. You might say, well, that's just where the sedimentary basins formed. Fair, but sedimentary basins exist all over the planet, and not all of them are rich in oil. Some are practically empty. Some were once oceans, but today hold nothing but dry, barren rock. Others, like the Persian Gulf, the Gulf of Mexico, parts of Russia, Venezuela, are overflowing. Almost too overflowing. So much petroleum that early explorers thought the Earth contained an endless supply. That alone should make you raise an eyebrow. How many trillions upon trillions of microscopic organisms would it truly take to create such colossal reservoirs? Enough to fill entire oceans with biological debris. Enough to saturate rock layers for hundreds of kilometers. Now consider this. Many oil fields refill. Slowly, yes, but measurably. Wells that were declared exhausted decades ago have later shown signs of pressure increases, new flow, new reservoirs feeding into old boreholes. How does dead plankton regenerate? It shouldn't, unless the story is more complex than we've been told. Let's go further back in time. Before we drilled, before we refined, before machines sucked the earth dry, ancient civilizations encountered petroleum naturally. The Sumerians used it for waterproofing. The Egyptians used bitumen in mummification. The Chinese drilled for it thousands of years ago using bamboo pipes. These societies didn't have the concept of organic origin. To them, oil was a product of the earth itself, an underground force, mysterious, powerful, sometimes even sacred. In some cultures, it was believed to be the earth's blood. In others, a gift from underworld deities. Myth, yes. Symbolism, certainly. But myths often emerge from observation, and the observation was clear. Petroleum seeped out of the earth as if produced continuously, not like a finite corpse buried and forgotten. Now, I'm not telling you that the conventional story is wrong. Science absolutely supports the biological formation of hydrocarbons. Organic shale, kerogen, heat and pressure converting carbon chains into liquid fuel. Thousands of peer-reviewed studies map the geological layers where this occurs. But even within the scientific world, there exist alternative theories. Some geologists, and notably entire branches of Eastern European and Russian scientific tradition, support the abiogenic theory, that petroleum can form from deep earth carbon, generated under extreme mantle pressures far below the layers where ancient life was buried. According to this view, hydrocarbons don't come from life. Instead, life might come from hydrocarbons. Hydrogen and carbon, the building blocks of biology, rising from deep within the planet, forming methane first, then more complex chains, migrating upward into porous rock until trapped beneath capstones. A geological process, not a biological one. This theory explains why oil sometimes appears at depths far deeper than biological sediment should exist. It explains why certain oil fields seem to replenish over time. It explains why hydrocarbons are abundant on other planets and moons, worlds with no oceans full of plankton. Saturn's moon Titan has lakes and rivers of liquid methane and ethane. Not ancient life, just chemistry. So why couldn't Earth have its own deep chemical processes at work? But then the mystery deepens even further, because regardless of origin, organic or abiogenic, the placement of the largest oil reserves still follows strange patterns. It aligns suspiciously well with ancient plate boundaries, catastrophic geological events, and regions of intense tectonic deformation. Some basins formed when continents collided, others when they tore apart. In certain areas, oil sits beneath what used to be lush prehistoric forests. In others, beneath what used to be shallow, warm seas. Millions of years separating them, yet both produce petroleum. Are they connected by biology or by geology? Or is it possible that what we call petroleum might not have a single origin story at all? Think about the fossils found near major oil fields, sometimes abundant marine life, but other times almost none. Think of the extraordinary diversity of petroleum's chemical makeup, from light, sweet crudes that flow like wine to heavy tar-like deposits thick as molasses. If all oil came from the same types of organisms, heated in the same way, shouldn't it all look, at least similar? And here's a question you're not supposed to ask. If oil is purely biological, why do some reservoirs contain helium, an element produced not by organic matter, but by radioactive decay deep within the Earth? How does helium migrate into layers supposedly formed from surface-dwelling organisms? Why does it appear locked in with the oil, as if the two substances traveled together from a deeper source? History, geology, mystery, they blend together into something far more intriguing than the simplified version you learned in school. The story of petroleum is not a single story. It is many stories woven over hundreds of millions of years. Stories of ancient life, yes, but also of planetary chemistry, deep mantle carbon, shifting continents, and the endlessly changing face of Earth. Could both theories be true at the same time? Could some oil be biological and some geological? Could some reservoirs originate from ancient marine sediments, while others seep upward from deeper unknown regions? It's possible. Nature rarely chooses just one method when it can choose many. Yet the biggest mystery remains: why do we insist that one explanation must fit everything? Maybe because uncertainty makes us uncomfortable. Maybe because the traditional narrative has been beneficial, economically, politically, scientifically, or maybe because the truth is still far beyond our comprehension. As you're hearing this, consider how little we actually know about the deep Earth. The deepest humans have ever drilled is a tiny scratch on the planet's skin. We've never reached the mantle. We've never seen where hydrocarbons truly begin. We rely on models, inferences, seismic echoes, assumptions. And assumptions, throughout history, have a habit of eventually being overturned. So the next time you pass a car on the highway, fly in a plane, or heat your home, remember that the fuel powering that moment might carry secrets older than humanity, older than life itself. It might be the liquefied remains of ancient oceans, or the primordial chemistry of Earth's interior, or something far stranger, something we have not yet discovered. And perhaps, just perhaps, the greatest mystery of petroleum is not where it comes from, but why it has been placed, concentrated, precisely where it is. Because if there's one thing history teaches us, it's that the Earth never does anything by accident.